All right, this is video 2 in the Algebra 2 4.01, solving systems of equations graphically. So the first thing we need to talk about, just what is a system of equations? You know, mathematicians always need to name something a little bit different, and really all that a system of equations is a collection of two or more equations. Collection of two or more equations. See if I can put that E in there correctly. All right, there. So it's a collection of two or more equations. And when we think about a solution to a system of equations, because we are solving, we need to ask ourselves, well, what is a solution? So remember that a solution, when we're talking about a one-variable equation, so we're going to talk about solutions of different kinds here. So a one-variable equation So a solution for that is a number that will make the equation true. So it's a number or a value that will make the equation true. And so let's look at an example there. So you can think of something like 2x minus 4 equals 10. And if we're going to solve that equation, we might, I think, add 4 there would be probably the best thing to do. So you get 2x equals 14. And then after that, we can divide both sides by 2. And we get x equals 7. Now, is it true that the number 7 will make that original equation true? Well, 2 times 7 minus 4 equals 10. So notice I'm just taking this equation and plugging in 7 for x right there. Okay. So 2 times 7, because we use PEMDAS now, so 2 times 7 is 14, minus 4 equals 10. Now on the left-hand side there, 14 minus 4 is 10. 10 equals 10. Yes, that's true. This is a good solution to the equation. It made the equation true. Now, when you think about a number, or excuse me, so we had a one variable equation. So now what about if we have a two variable equation? Well, a solution to that will be a pair of values. Since there are two variables, a pair of values that will make the equation true. And so if we think of something like, let's have an example, 2x minus 3y equals 6. Okay, now how would we solve something like this? Well, we can't. We can't just solve. So I'm going to plug in a value for one of the variables, and we'll solve for the other variable. So I'm going to let x equal, let's say, I think 9 will work out nicely. Sorry, I needed to do a little bit of quick math in my head there. So we're going to let x equal 9. So we'll have 2 times 9 minus 3y equals 6. So now to solve here, well, 2 times 9, that is 18 minus 3y equals 6. And now I'm going to subtract 18 from both sides, and I get negative 3y equals negative 12. Our next step here is going to be to divide by negative 3. And I will get y equals 4. So now I can plug in my 2 points here. I'm going to do that in, let's use this color here. So we have y equals 4. So I'm going to do 2 times 9 minus 3 times 4. That's supposed to equal 6. So again, I'm plugging in 9 for x, I'm plugging in 4 for y, and then I just have my original equation with those plugged in. 2 times 9, that is 18, minus 3 times 4, that's 12, equals 6. 18 minus 12 is 6, equals 6. And so that is a good solution. It makes the equation true. Now, the thing here is that there are infinitely many solutions that would make this equation true. So we have to, we can't just solve it. That's why we couldn't solve in the first place. So then the question is, if you're thinking about a system of equations, then what's that going to be? Well, a system of equations, let me see, I'm just going to go to a new slide. So if you're talking about a solution to a system of equations, well, if you think about we're talking about 2 lines, well, it might be like this. Here, let me use nice straight lines. In that case, the solution is, and I should have used different colors here to make it more obvious. So in that case, the solution is a specific point. It will be an XY coordinate point. And so that is one possibility. Another possibility, when you think about those lines, is that they are, one's there, and then I don't know that I can do this just perfectly. We'll see. They're overlapping like that. And I think what I should have done is made this one bigger so that you could see it. Let's see. And then this one smaller. Like that. So you can see there that they're overlapping. And so if you think about the solutions there, well, what the points are all along it. And in fact, we could zoom in and find more points and then zoom in and find more points. So in this case, there are infinitely many solutions. Oops. And those solutions are all of the points on the line. So all of the points that would make the lines true. And then the third possibility, and let me see about this one. Oops, go back to this. So now I'm going to copy that and then paste it so I can get a nice example there. So in that one, notice that there are it doesn't overlap anywhere. And if they're truly parallel, those points will just never overlap. So there are no solutions. So what you can think of is up here they intersect in one place. Here they overlap. And here they are parallel. So that's the way that you can think of the kinds of solutions that you're going to get when you're looking at a system of equations and what the graphs will look like in those cases.